Good day to our lecturer. We are from Group 6. My name is Joey. Our group are going to present Mechanic of Material group project. For this project, we are analyzing the structural behavior of a beam under a bending test using an unconventional material, uncooked spaghetti. For this project guidelines, our group is designing the equilateral triangle cross sections. We have fabricated a bar that is exactly 30 cm long and 1.5 cm thick. We will test this triangle model by hanging a water bottle from it. Gradually increase the water volume as our load until the bar break apart. Our core objectives are to build the model using a Moore, record the breaking load, generate the shear force and bending moment diagram for all test load, and calculate allowable normal stress using a safety factor of 1.5. Let's look to our model.
So this is our model. The shape is equilateral triangle. The material we use spaghetti, and we stick it together by using hot glue gun.
So the shape of our bar is a triangle. Each of the sticks range from 28 or 29 centimeters to 31 centimeters in length. So we used a total of 35 spaghettis. Each of the spaghetti was sorted off from the packet. We chose the closest length to 30 centimeters among all the spaghettis. So we tied it all with a rubber band, and we first sealed the top part of it with a hot glue gun. Once it's dried off, we did the same thing to the bottom. Once both sides dried off, we made a spiral of hot glue to further reinforce the structure.
Okay, so for the molar testing, we use 0.2 kg increment because for the uncooked spaghetti is quite brittle. So if we start with, let's say like we start with 1 kg, so the bar might snap instantly on the first try. So we start with the 0.2 kg, so we can ensure that we can capture the initial elastic deformation. The other reason is by increasing by 0.2 kg increment, we can get multiple data point before the bar is ultimate tensile bending strength. And the other reason is for the 0.2 kg, we can measure accurately using a standard measuring cup or a graduate water bottle.
So this is 0.2 liter load.
We are going to test 0.4 liter load. Let's go.
So now we have 0.6 liters of load, and we would like to try to hang it on this. And I'm going to put it in 3, 2, 1. As you can see, the load withstands the.
So right now, we will test for the 0.8 liter.
So now we are going to test the 1 liter load. Let's go.
So now we have a 1.2 liters of bottle. So we will put it right here. 3, 2, 1. As you can see, it withstands.
This is 1.4 liter load.
Now we are going to test the 1.6 liter load. Let's go.
So now we have 1.8 liters of water, and we can see. Okay, I'll be dropping it. Serious, Guys, as you can see, it broke at 1.8.
Alright, to continue with our calculation, we'll be starting off by calculating or finding the mass of our volume, which is 1.4 liter and 1.6 liter. So, as we know, to find our mass for this both volume, we need to use the formula of M equal PV, which P is density of water while V is our volume. So beforehand, we need to convert our volume, which is in liter, into meter cube to calculate our mass. So in order to convert our volume into meter cube, we need to divide our volume with 1000. So it will give us the first volume, which is 0.0014 meter cube, and second volume is 0.0016 meter cube. So just then we can calculate our mass by using the formula of M equal PV. So in this calculation, we will assume that the density of water is 1000 kilogram per meter cube, and by that we will get the mass of mass 1, which is 1.4 kilogram, and mass 2, 1.6 kilogram. After that, we need to calculate the force of these two mass. So in order to calculate the force of these two mass, we need to multiply them with gravitational acceleration, which is, in this calculation, we assume that the gravitational acceleration is 10 meter per second square. So calculating the force, we will get the value of force 1, which is 40 Newton, and force 2, which is 60 Newton. So after calculating both the force of our mass, we need to build a diagram or draw a diagram of our test that consists of two supports and one force, which is our water, exactly in the middle of our structure, which is 15 centimeter from both sides. So this will be our diagram for both of our force. Okay, continue. So let's start with the calculation of force 1, which is 40 Newton. So before we find the V value and the M value of our diagram, we need to find the Y component of both support, which is A and B. So in order to calculate for By first, we need to use the summation of moment at A. So after calculating for the moment, we will get the By value of 7 Newton. So next, to calculate for Ay, we need to use the summation of Fy, which will give us the summation of Fy equal to 0, which will give us the value of Ay equals 7 Newton. So after getting the both of this Y component, which is Ay and By, we can calculate for the V value of our structure. So by using the segmenting to calculate all of this value in our structure, we will get the value of V equal to first 7, and then for the second segment is 7 too, and for the third segment will be -7, and the fourth segment will be -7. So after calculating for the V value of our structure or our segments, we can find the value of M, which is moment, in all our segments. So in structure 1, we will get the moment of 0 Newton meter. In structure 2, in segment 2, we will get the moment of 1.05 Newton meter, and in segment 3, we will get the value of moment 1.05 Newton meter, and last but not least will be the fourth segment, which will give us the value of moment 0 Newton meter. So after getting all the V's value and the M value of our structure, we can build a graph of V, which is in Newton, versus distance, which is in meter. So by plotting our value of V in our graph, we will get a graph that will be looking like this. And for the moment, just the same, but in this scenario, it is a graph of moment in Newton meter versus distance in meter. So by plotting our M's value in this graph, we will be getting a graph that will be looking like this. So after calculating for the F1, the V's and M's for the F equal 40 Newton, we will continue with our second F, which is 16 Newton. So there's not much difference in calculating for V's and M's by using F2, which is 16 Newton. The only difference there will be is the value of V and M. So by calculating for our V's, we will be getting our first V, which is 8 Newton, and our second V will be 8 Newton, and our third V will be negative 8 Newton, and our fourth V will be negative 8 Newton. So after calculating for V's, first we need to find our M value, our moments value, which will be resulting in our first moment will be 0 Newton meter, and our second moment will be 1.2 Newton meter, and our third moment will be 1.2 Newton meter, and our last moment will be 0 Newton meter. So after calculating for V's and M's for F equals 16 Newton, we will be getting a graph of V versus X like this, and M versus X like this. So this will be all of our calculation in order to build or draw the graph of V and M, and that is all our calculation in this test.
In conclusion, upon demolished by 1.8 liter of load, our structure can only withstand up to 1.6 liters of load. By performing calculation to find M's and V's values, we are able to construct graph of V versus X and M versus X for both 1.4 liter and 1.6 liter loads.